All right, class, now we're going to look at a concept called formal charge. Again, this may be a new concept. Some of you may have learned about formal charge in sophomore chem, but I'm going to go through it. Formal charge is a tool that we can use to evaluate a Lewis dot structure that we've drawn to make sure that that Lewis dot structure is, we would say, the most likely Lewis dot structure. The more you do Lewis dot structures, you find that sometimes you end up with a case where you can draw two different Lewis dot structures that are both valid, everyone has an octet, but the atoms are arranged in a slightly different way, or maybe there's a double bond or a triple bond in one that maybe there's a single bond in another. And what you want to do is, at the end of drawing those Lewis dot structures, if you have several structures, you need to evaluate which one would be the most likely, or we say the most plausible. This evaluation is most important when you look at your Lewis diagram and you see that it's valid, but some of the bonding is not typical. We may say it's atypical. Now, what are some other typical bonding? Well, nitrogen likes to bond 3 times and have an unshared pair. So three singles, a double and a single, or a triple. Oxygen, you know, likes to bond twice and have 2 unshared pairs, typically. So 2 single bonds or 1 double bond and the 2 unshared or lone pairs. Halogens like to bond once and have 3 unshared pairs around them. Again, these are what we would call typical bonding, and if we ever have any not so typical bonding in our Lewis dot structure, we may want to evaluate it using formal charge. Now I'm going to go over how to calculate formal charge, and I'm going to go over it with a typically bonded molecule, nitrogen trichloride. Notice the halogens in this molecule are bonded the way halogens like to bond, and nitrogen is bonded the way nitrogen likes to bond. Okay, well, this is a good example to show how to calculate the formal charge. And let's look at the formula for calculating formal charge. Now, as I scroll down here, I want to just note that formal charge is not a charge. It is a bookkeeping tool to evaluate a Lewis dot structure. It's not, these compounds are not ionic, they're covalent, they don't have a charge. Chlorine doesn't have a charge, nitrogen doesn't have a charge. Formal charge is not very well named, but think of it as more a bookkeeping tool to evaluate your Lewis dot structure. So to calculate the formal charge, for each element bonded together, you're going to look at the number of valence electrons. You're going to subtract from that, in this quantity, half of the bonding electrons plus any unshared electrons. And so you can write that as formal charge equals the valence electrons minus half the bonding electrons plus the number of unshared electrons. Now let's go through that for NCl3. Let's look at this chlorine here first. And here's kind of how you typically do it, guys. You draw a little arrow and you say, well, chlorine starts out with 7 valence electrons before it's bonded. There's 2 electrons in here, but I'm going to subtract from that half of that number of bonding electrons around here, so 1. And then I'm going to add to that the number of unbonded or unshared or lone pairs of electrons, but you count all the electrons, 1, 2, 3, 4, 5, 6. And what you find is when you calculate the formal charge on chlorine, it has a formal charge of 0. You can see that it's the same for the other 2 chlorines in this molecule. There are 7 valence electrons, minus 1, because 2 divided by 2 is 1, half the bonding electrons, plus the 6 unshared electrons, gives you 7 minus 7, 0 formal charge. And again, this chlorine has the same bonding arrangement, so instead of going through it in the interest of time, we'll call that 0. Okay, let's look at nitrogen. Kind of draw the arrow like this. So nitrogen starts out with 5 valence electrons. I'm going to subtract from that 1, 2, 3, 4, 5, 6 divided by 2, or 3. So half the bonding electrons on that nitrogen is 3. And I'm going to add to that, 2 unshared electrons. 5 minus 5 is 0. Now, again, these guys are all typically bonded, and what it turns out is that when elements are typically bonded, the formal typically bonded like these over here, the formal charge in them will be 0. So in this case, each atom in this Lewis dot structure has a formal charge of 0. And when that happens, that is going to be your most likely Lewis dot structure, especially if you have a different structure drawn that doesn't have all 0 formal charges. Now let's go through an example of how we can use formal charge to decide between some plausible Lewis dot structures. Why do I say plausible? Plausible Lewis dot structures are ones where all the elements have an octet or an expanded octet, I guess, but in this case, carbon dioxide would not have an expanded octet. It is possible to validly draw the Lewis dot structure for carbon dioxide, like the first one on the left, so 2 carbon in the middle, 2 double bonds. But if you look at the second structure, the one in the middle, well, carbon has an octet with its triple and single bond. This oxygen over here just has 1 single bond, but it has 8 electrons. And the oxygen on the left has 8 electrons. Okay, let's go over here. It's possible, instead of putting carbon in the middle, to put oxygen in the middle. And you would end up with this Lewis dot structure. Again, all of these guys have an octet. But which one of them is the most plausible? Or the most likely? For that, we need to look at formal charge. All right, guys, let's look at the first Lewis dot structure. Oxygen starts out with 6 valence electrons, has 4 bonded electrons, so divide that by 2, plus the 4 unshared individual electrons. That oxygen has a 0 formal charge. Carbon starts out with 4 valence electrons, has 8 bonded electrons, so divided by 2 is 4, has no unshared, it has a formal charge of 0. This oxygen, bonded the same way as the first oxygen, also has a formal charge of 0. Looking at the middle structure. The first oxygen, again, oxygen starts out with 6 valence electrons, has half of the bonded electrons is 3, has 2 lone electrons. It has a formal charge of +1. And look, it's bonded atypically. It's not bonded the way oxygen likes to bond, which is either two single bonds or 1 double bond. So this +1 formal charge is not surprising. Again, this oxygen does not have a charge of +1. It is a bookkeeping term. Carbon in the middle has a 0 formal charge. The oxygen on the right-hand side, 6 valence electrons, half of the bonded electrons is 1. It has 6 unshareds. It has a formal charge of -1. Lastly, carbon, oxygen, oxygen, CO2. First carbon, 4 valence electrons, bonds 2, unbonded 4, the -2 formal charge. Oxygen in the center starts out with 6 valence electrons, 4 bonds, no unshared, formal charge of actually +2, sorry. Oxygen on the end, look, it's bonded typically. Remember, oxygen likes to have 2 bonds and 2 unshareds, and lo and behold, 6 minus 2 plus 4 gives you zero formal charge. Now, how are we going to use this to evaluate? Well, the Lewis diagram will be the most likely of these plausible ones if it has, first of all zero formal charges. So in this case, this first Lewis dot structure compared to the other two would be the most likely. Okay, it has all zero formal charges. Well, sometimes though, you have the only structure might have a formal charge of, let's say, +1 or -1 overall. Or they have, like the center one, you have a +1, a 0, and a -1, and they add up to 0. If all the formal charges add up to 0, if you don't have any all 0 formal charges like the first one, the next best thing is to have your formal charges add up to 0. Or if they don't add up, like if you have one like this one, look, the one on the right, it will eventually add up to 0, but you see how its formal charges are larger. It's a -2 and a +2 and a 0, right? You want to go for the lowest formal charges overall that add up to 0. Again, sometimes you end up with a formal charge of -1 or +1 overall. It's okay as long as no other structure has 0 formal charges. Okay, so you get to go, you'll be doing a worksheet, and you can look at some of the examples that I gave you, and hopefully you'll be able to get this. If not, again, check out Mr. Kent Chemistry. He also has videos on formal charge, and he might be able to catch you up.